Hey everyone. So today I participated in Google Code Gym qualifier round, and there were five problems in this round, and in order to qualify to the next round, we need to have a score of I think 30 points or more. If you solve like first three problems, that should be enough to make it to the next round. Um, Yes, so in this video, I'm going to talk about my solutions to the first four problems. I was able to solve the first four problems. So I'm going to discuss all these problems. I'll start with the first problem. I'll not go through the problem statement. I'll just, go to the test cases. In each test case, we're given some two numbers, which is number of rows and number of columns, and we need to print a pattern like this. In the first test case, we are given three rows and four columns. So basically, you'll have three rows and four columns. So if you think about this, every box is nothing but uh, uh, a pattern, like you'll have plus at the corners, then you have these lines, horizontal lines and hyphens and dot. This is a pretty straightforward implementation. So the only corner case or slightly modified thing is you'll have these four dots in the beginning. So this is pretty easy to handle. Like I made the very generic pattern first, and then at the end I replaced the first four these four characters with dots. Uh, so nothing much to the problem. Yeah, um, this is my solution. So basically, what I did was I printed this first row. So this is my code to print the first row, which is actually the first three horizontal lines. And then for every other row, you just have to print this line and this line. So basically, two lines for every row. This there was nothing more to the problem. It's just some if else conditions, and then yeah, nothing much. I'll go to the next problem. The second problem says that okay, you have uh, three printers, and you have these four different colors in those printer, and you're given the values of these colors. So printer one has this much quantity of color one, this much quantity of color two, and so on. And you want to print one character, and so that character should have the total combined value of I think 1 million. Yes, so that should have a overall combined value of 1 million, and you should be able to print that from all the three printers, correct? So let's say if I choose 10 from here, 20 from here, something from here, something from here, I will have to choose the same thing from here, and same thing from here, and then again the same thing from the very first printer. So, so the color combination should be same from all the three printers, and the sum of values should also be same. That should be 1 million. So if you see the first test case, it's possible to do that. We can choose, 3 lakh from the first one, then 2 lakh from the second one, again 3 lakh from here and 2 lakh from here. So all these values are actually greater than, their corresponding values. In case you're not able to print one character, which satisfies that 1 million condition, and having the same color combination from all three printers, you'll see it's an impossible case. Like the second test case is an impossible case. So basically in this problem, for every color, you can say that this is the maximum value I can have in my final character. So if I talk about third test case, this one, we have these three values, 7, this value, and this value for color 1. And the maximum we can choose is should be the minimum one, right? So this is the maximum value we can choose for that common color, right? So from for color C1, we'll have this maximum. This is the maximum we can take. From here, this would be the value, basically the minimum. So you take the minimum from all different colors. So this one, and then for color, next color we'll have this value, and then finally we'll have this value. So you'll have these four values of colors. You cannot exceed, more than these colors, because in that case, one of the printer will fail to uh, do so. So now you'll have these four values. You can simply check if the sum of these four values is less than 1 million. That would be an impossible case. But if it is more than 1 million, you can just greedily, greedily take as much as possible as soon as you hit 1 million. So yeah, I'll simply go over my solution. Yeah, it's nothing much. Yeah, so what I'm doing is taking the minimum over every color, and then if the sum of those minimums is less than 1 million, you say it's an impossible case. Otherwise, you greedily, you'll define. I have defined a variable which is 1 million, and I try to take as much as possible from every color, and I'll not exceed more than 1 million, right? So this variable gets updated to that value, whichever I'm outputting. So this is a one greedy solution. So yeah, that's more or less about the second problem. There was nothing uh, much to that other than that. So for the third problem, basically um, you're given okay a set of dice, and what you want to do is you want to select a certain number of dice, such that the value on those dice will form can form numbers from 1 to L, and you have to maximize that L. So if I have to explain this, so if I take the first test case, just 6, 10. Okay, let's take the second one. That's I think more appropriate test case to explain this. So basically, you're given these, six numbers, and you have to tell how many dice you can take such that you can form 1 to L, numbers from that. Okay, so these are so when you say a dice of value 5, then this dice can generate values from 1 to 5. This can generate from 1 to 4, and so on, right? Okay, so um, the one possible solution is you can get 5 from here. You can get 4 from here. You can get 3 from here, 2 from here, 1 from here. But yeah, I cannot get a 6 from here. So the maximum possible consecutive, numbers I can get is 5 numbers, 1 to 5. Correct. So the answer for this test case is 6. Um, Now, how do we approach this problem? This is actually a greedy problem. You have to you sort all these numbers, and then um, you start from the smallest number and go toward the largest number every time you try to form the next possible number. So what I mean by that, so if I take this test case, if I sort this will become 4, 4, 4, and then you have a 5 followed by 6, and I think 3 sevens. Then you have 2 tens. Did I miss something? Okay, no. It's cool. So once you sort that, now, yeah, how I'll proceed this, I'll make a 1 from here. I can make a 2 from here. I can make a 3 from here. Can I make a 4 here? Yes, I can make, because 4 is less than 5. I'll make a 5 from here. Okay, I can make a 6 from here. I can make a 7, but I cannot make a 8 here, right? because 8 will exceed 7. So yeah, this number will be skipped. Then I can make a 8 here and I can make a 9 here. Correct. So for this test case, my answer would be 9. I can make 9 consecutive numbers from 1 to 9. So yes, so the answer would be 9. And yes, the coding part is also like pretty simple. You sort all the numbers and then go over numbers in the increasing order. If the current number was less than equal to the required number, you increment your answer and do a current plus plus on that number. And finally, you just print your answer. Or you could have, or I could have just printed curve. Yeah, that's also possible. So this was also a greedy problem. There was nothing more to it. Yeah. Finally, the last problem was which I solved was this chain reaction, and yeah, so this was slightly harder than other three because they were very straightforward. So in this problem, what you're given is you're given essentially a tree. Okay, so you'll have a tree. So if you talk about this, then this last part, where 60 is pointing is your root node. If you think about this as a tree, then so you're given. So what you can do is you can start from any leaf node, and from that leaf node, if you start a chain reaction, then that chain reaction will propagate to the root node. Correct. So in that whole process, you'll so the value you'll get from that operation would be the maximum number you encounter on that path to the root node. So in our case, let's say if I start a chain reaction from node this fourth node with the value 50, it will propagate to node number 2 with value 20, and then node 1 with value 16, finally to the root. So the maximum value I encountered was 60, right? So 60 would be my value from this iteration, correct? And then I have to do this process for every leaf node. So the only other leaf node I am left with is 40. So now I start a chain reaction from this third node with the value 40. And this will go also till a root. But the thing is, so since 60 was already, part of previous chain reaction, so that cannot be used anymore. Correct? So all the nodes which are used up in some other chain reaction, they cannot be used anymore. So in this case, the maximum value we'll get is 40. 60 will not count because 60 was part of a previous chain reaction. So answer would be 100 for this if I follow this order of this order of starting the chain reaction. But in case, let's say if I did start from the third node first, so in that case, I'll get from 40 I'll go to 60. Then I'll go to the root, which is so the maximum I'll get is 60. And then I start from 50. So next from 50 I'll go to 20, and then to 60, and finally to the root. And the maximum I got was 50 because 60 is already used up. So 110 would be the score in that case. And this is actually better than doing this. So in this problem, basically, you have to do some optimal, strategy to, start these chain reactions such that the final score is maximum, right? So, um, how do we do that? So the very first thought I had in my mind was, you'll do some kind of you know so for so the very first thought, which was actually incorrect, came to my mind was, I'll start from those leaf node who have the smallest value. So yeah, if I have to explain this question, then I think the best test case is the last one. I'll simply, I have an image for that. Yeah, I'll open that image. Right. So, in this image, you can see that 0 is my root node, and all these values, all these nodes have values associated with them. Leaf nodes are 6, 8, 5, 4, and 7. Um, so, in our example, node number 5 is the smallest value, which has a value of 80. So what I was thinking was we can start chain reaction from 80 toward the up, and then yeah, we'll do the same for the next smallest value. But this had an issue because so if I start from 80, that is node number 5. I'll go to node number 2, then node number 1, and finally to the root. So the maximum on that path was, I think, node number 2, which had a value of 20. It had a value of 20. Sorry, not 20, 100. It had a value of 100. But in this whole process, this node number 1 also get used up because it's on the same path. So now these 4 and 7, they when you start a chain reaction from them, this node number 1 will not, will not be part of that chain reaction because it's already used up. But this node number 1 had a value of 100, and this node number 4 had a value of 90, and this also had a value of 90. So a better approach was, if you start from node number 4 first with the value 90, you go to node number 1 with a value 100. So for this iteration, you will have 100, as a score. And after that, I can start from node number 5, uh, go to node number 2, then 1 and 0, and in that case, my 2 will contribute a score of 100. So we'll get two different hundreds, right? So, so actually, the logic of starting from the smallest and propagating to the very top is not correct. So that was the first idea I had. Um, if I thought about this, and then yeah, finally realized that this approach is not exactly wrong. You just need to make a slight modification to this. And that modification is, instead of going to the very top, you you now also start from the smallest value leaf node, but you do not go to the top. You'll just stop as soon as you get a slightly better value. So if I say, then node number 5 had a value of 80, and so when I go up, I'll go to node number 2. It had a value of 100. So I'll stop at node number 2. I'll not go to 0, right? I'll not go to 1 and then 0. I'll just stop here because I've got a better result, right? So what I did was, I maintained a like sorted sorted list of these values. So initially I'll have all my leaf nodes with their values in a sorted list. Now I pick the smallest node, which in my case would be 5. So yes, for that I'll process. So this will go to node number 2, and it will stop here, right? So now this node number 2 will be pushed to the same data structure or set, whatever I maintain. This 5 is popped out now. This is no longer part of that set because this is processed. So currently in my case, I'll have 6, 8, 2, 4, and 7 in my queue, in my set or queue, whatever I'm using. Um, so yeah, I'll do this for every. So I'll now find out the next smallest, which in my case would be, I think, 4 or 7, anyone. So let's say it was 7. Then 7 will go till 1, and then because my score is improved from 90 to 100, I'll stop here. 7 will be removed from the list, and this will 1 will append to the list. Yeah, finally, so this process continues. So as long as all the nodes are not removed from the queue, right? So the next iteration would be, if I proceed further. So 4 will be the next smaller number, next smaller value, which is 90. So for 4, 1 is already visited, so I don't go ahead. So this 4 will finally add to my answer, and this will be popped out, and nothing will be popped into the set or queue. So this way, my set size will keep on reducing, and finally, when I'll have my answer as elements are popped out, I'll just add them to my answer. Yeah, I'll just go over my solution now. Um, right. So yes, so I maintained a set of leaf. So initially, I say all the nodes are leaf, and then for every parent, I since it is a parent, so it cannot be a leaf, so I just removed that node if it's in leaf. So now finally, I'll only have leaf nodes in my leaf set. And then this is just resetting the visited array. So I maintained a set of pairs. Um, so this pair is nothing but the value of the node and the number of the node number basically. So I put so for every leaf node, I put the value and that node number. Now, while this set is not empty, I'll just take the first element from the set, remove this first element. This is the current, since it's the second element of the pair, so that's the node number. And from that node number, I call a function which is get better. So this get better, what it does it goes up the tree and find the closest possible value which is greater than my value. So I passed that value here. So if I found that value, I just simply return that node. And if I don't find it, I simply return a -1. Correct? So if I get a -1, in that case, I increase my answer to that value. And that value would be, we'll get that from the set, right? The first element. Otherwise, since we've got something better than the current node, we'll push that node into the queue now. And this keeps on happening as long as we have some node in the set. And also note that when I'm going up the tree, I'm also marking the nodes as true, visited as true. So that I never visit the same node twice. So as soon as I try to visit the same node twice, I'll just simply say that this is already visited, and all the nodes above it are already used. So we'll say that it's -1. You're not going to get a better result for the current node. So finally, I increment my answer every time a node cannot find a better node for itself. And then yeah, just print the answer. So this is I this is a DFS problem basically, tree DFS. There's no DP here. Maybe you can do it with DP, but yeah, greedy also works here. Um, so these were my solutions to the first four problems. I didn't I didn't solve the last problem because the number of submissions are already very low. And anyway, you don't need it to qualify to the next round. So yes, so that's all about like my solutions to the first four problems. Hope you understood. Like if you had any doubts, you can just put them in the comment section. And yeah, thanks for watching.